The invitation this morning. I've got a little teaser bag of toys here that I've brought in, so I'll show you some of that in a second. We are a very small, compact drone manufacturer and marketer. And the primary difference between us and almost any drone you will have seen on the market is that we can deploy the device very quickly. Our design is based around the fact that the blades that cause the vehicle to fly are not exposed on the outside of the vehicle. They're tucked away on the inside of ducts. What that gives you is a couple of different advantages. One is that you're less likely to shred your fingers or your friend's face or anything like that when you're flying. You also, because the delicate items of the vehicle are tucked away inside of the interior of the vehicle, the huge advantage is that you can deploy the vehicle rapidly. Our target markets with the vehicle is in the police and rescue space. In that particular space, the time to deployment is essential. The Deputy Chief of the New York Fire Department was telling me that they would save an innumerable number of lives if within the first minute or two of getting to a fire, they knew whether the fire was coming out of the front or the back of the building. It would totally change the way they deploy people inside of the building for firefighting. They'd be able to save far more property and, more importantly, in fact, save far more lives. So, there we go. So, existing UAVs that are in this sort of space, well, first off, the market in terms of the police and rescue services is very, very large in potential. Very few vehicles have found application in this market because they're hard to deploy. The vehicles have been available, have been priced in the $40,000, $50,000, $60,000, $70,000 regime. And it's clear that what's needed is something far more simple, robust, reusable, and that can be applied and used within the first 30 seconds of getting to the scene. And that's what we think we've got in the combination of our technologies. Our staffing, myself, I'm a former professor at Caltech, had a research group there for 10 years in planetary science. Larry Lambert, my vice president, has an enormous career stretching back through Navy SEAL activity, Orange County District Attorney's Office, vast connections across law enforcement. Our chief technology officer is one of the brightest people that I know, and is called for most of the inventions that we have in the company. And Greg has made all of this from a nerd's dream in a basement into something that's a great company that we're doing something with. So, this is the size of the marketplace right now. It's a little deceiving because a lot of these numbers currently, looking back on the market, is based around big predator drone type drone vehicles. The actual car growth in terms of usage for the types of applications we're talking about in commercial space, that has gone from barely anything about 2 years ago to almost $500 million over the course of the last 18 months. That's the space that we're in. I don't think there's very much time to go over too much more than that in the time that I've got here. I'll try and see if I can still make it to the forward click over side. Top one. Yeah. Is it possible to manually click forward? I think I've lost. Okay. So just keep on clicking through. And this was a longer form slide presentation set up for a half-an-hour presentation. So I think what I will do here, with time constraints that they are, is I'll just fly you the device and you can take a look at it. We can go over questions and answers with regards to what we're doing, stages that we're at, etc. So I'll put the microphone down and I'll get the vehicle together here. So this vehicle is designed ultimately to work off of a tablet that we have that allow you to very simply and easily use the vehicle. This is a 3D printed. We have the main vehicle in production right now, and I have not brought that one. The vehicle that's shown on the diagrams is about this big. This is a much smaller vehicle. The nice advantage of that is you get two instead of a box this size. And with regards to the idea of being able to just get the vehicle out and go and fly, I don't have to put any blades on, don't have to do anything to it. We're ready to go. I have to actually attach the battery here, but on the version that we will be selling, you don't have to do that. I'm just going to put my microphone down for a second and attach the batteries. That's a nice beep that tells that it's alive. And then this is going to jump off the floor a little bit when I first started up. And there we go. Just make sure it's twinned, and then we'll jump it up, and I'll try and show you some of the advantages of the vehicle in flight. It's going to be a little bit loud as well, so just FYI, it's going to usually designed for flying outside, so flying inside is a little bit exciting. So, power it up. There is I can just pick it out of the air and there's no danger of me cutting my fingers off or doing anything like that. So anyway, loud demonstration for indoors. So that's a rapidly prototyped, extremely 3D printed model, so the design on the outside isn't final. You can see it's a very rough textured surface. But yeah, so where we are is that we were established back in 2011, but really as sort of like a concept level company. We ran this rather like a research program for a while. We were properly funded up and fully staffed up in July this past year. We have a significant number of orders on book to fulfill for the larger vehicle that I was talking about. We are in the very, very last frustrating stages of assembling those vehicles for the first shipment. We're going through all the usual things that you have when you have vendors producing electronics and plastics, and they don't produce it quite the way you want to do, and you go back and you recycle through. But I think the thinking is that we'll actually have the first products out to customers in the next few weeks. And also thinking now about how we can start to exploit some of the consumer sort of flying selfie products, where you can use it as a camera for looking back and taking photos of yourself doing all sorts of interesting and potentially silly things. So yeah, that's in a quick nutshell.
What's the cost?
The cost for the vehicle, the larger vehicles with the larger payload suites can cost all the way up to about $10,000. When I was talking about the goal for having the vehicle that's in the side compartment of every squad car or police car, the goal there is to get that price down to under $2,000, or to get it into a leasing. Actually, we've talked a lot about putting that into a leasing program. And then a vehicle like this that's a little toy, be getting down to the point where you can pick one of those up for like $399, $499.
Question for you. I know with the incident at the White House this weekend, I never was aware of this. They said the battery operations almost of drones aside less than 20 minutes.
Oh yeah. Yeah, so typically a vehicle in this size category is anywhere from 5 to 20 minutes. They're not long flight time vehicles.
The battery dies, it drops.
No, well, ours doesn't. When the battery dies, the flight computer knows what the voltage of the battery is. The voltage is draining down. What ours and several of the vehicles in the market do is they notice that and say, I'm running out of battery. I'd better start to descend slowly and come to the ground. I could actually run this. It's sort of tedious. I could run this one out until battery dies, and you'd see it would just come down and then it switches motors off. But yeah, some of them don't have that feature.
What are the largest models made?
The largest model we make is about it's 33 centimeters across. So in Imperial, that's what, about 13 inches, I think. So but it's that big. And the reason for that is that once you start to get over size ranges of that, that size for us, because most of our volume is in battery, you get to the point where they're really too heavy to move around with one person. And so we decided that we wanted our threshold to be, if it's too heavy for one person to move around, it's not really very useful to us. But for the specific application that we're doing.
Could you elaborate a little bit more on the use for public safety and industrial?
Yeah, so the use for public safety, so I went over the fire application. The police applications are just, it's the complete gap in short scale reconnaissance. So we've got police helicopters, we have various vehicles like that. But one core example of an application is low-rise suburbs where a police can get called out because an alarm has gone off a house. Part of clearing the alarm is to be the ability to go and check the roof and to check the backyard to make sure that there's no burglar hanging out still in there. As it is right now, they really don't have any option. You can't call out a helicopter for that. They've just got to get over the wall, go and take a look. They have to go knock on the door. They have to potentially get up on the roof, especially for commercial checks. And each one of those cases, you're putting an officer in danger because if there's someone there with a gun, you're potentially in trouble. With this, for a few $100s, you've got something that can go out, a few hundred or a few $1,000s, you can go out and take a quick look. So it really is sort of like filling in that blind spot that exists between what you can see with your own eyes and that's maybe about a couple of 100 feet away from you. That's really the gap that we're trying to solve with this device.
Have you run into any regulatory issues or things where municipalities or other government agencies don't want these things flying around? Or
yeah, so on the hobby level, there are no regulations at all. So if, as a private individual flying one of these things, I can do whatever I like, wherever I like, as irresponsible as it is. On the police and fire safety, the whole public safety domain, it falls within an area of the FAA guidance where you have to apply for a waiver to be able to fly the vehicles. But that's more than anything just so FAA can track how many different departments are using them. It's a relatively straightforward waiver because the application is so important there. The limits are that the vehicle can't be flown more than 400 feet away, has to be in line of sight, and there has to be an ability through radio to be able to patch through to a local flight tower via an airport if the vehicle gets into trouble. And that's all reasonable within the way we've designed the vehicle. And then for commercial applications, we're talking about things like inspection of drills, oil rig towers, construction site, a variety of things like that. Hollywood filming. As they come along, the FAA is granting permission to companies to use those so long as they can satisfy some sort of minimum requirements about how they're going to be using the vehicles.
Whereabouts is your manufacturing, even though you've got modern components and your assembly?
Yeah, so our assembly is right now is in San Dimas in California. Our parts come from a mixture of some of our electronics are made up in Reno, Nevada. Our plastics and some of our electronics are made in Shenzhen, China. And they're all shipped back to California and they're assembled there. There's a lot of options for where we do both the electronics and the plastics. We went with those because they were the right mixture of could maintain our minimum quality levels and were the cheapest ways of going. But we control. The other interesting thing is we control the vertical integration of all those components. So we design the electronics boards, we design all the plastics components, so we can move them around from vendor to vendor as it expedient for us to do so.
And I'm sure you had it in your larger presentation. You guys are targeting kind of that public safety edge. I mean, you talk about the silliness. I can see it being very easy to be distracted because you could get into any number of spaces with that application. How crowded? Who are you competing with for a public safety application?
Well, the public safety application has been one where it's been talked about in the media for I think about like 6 or 7 years since the open blade vehicles first came along. And there really is a very limited amount of penetration into that market. And the primary reasons have been because the vehicles have been very expensive. Departments don't tend to want to buy very many of them. So they'll have one big shiny one that sits in the captain's office or the sheriff's office and it never gets used. And also because I almost brought an open blade system in, but because it's so cumbersome to pull out of the car and bring up here, I decided my scramble to get in time to leave it in the car. But that also tells you something about the utility in general for police officers and firemen. If it's going to take them 5-10 minutes to break out the thing and use it, they're not going to use it because they've been in dealing with the problem by the time they get there. So in terms of that, there's actually very little competition in the space for these types of, for our particular type of device in the public safety market. In the consumer market, obviously the competition is all over the place. You've seen all those vehicles, the Phantom flyers, the Iris flyers, and I think there we're just going to sample the water to see whether people are interested in having non-exposed fans and compact flyers. But there the competition is rife. It's just very intense.
question.
Sure.
Payload capacity.
Our design philosophy is we tend to design the vehicle structure around the payload. The excess capacity that we have in that small castle vehicle there is only a few hundred grams, which is a few ounces translated. But that's enough to fly like a little thermal infrared camera, a very high resolution camera. On the larger vehicle, we have almost a kilogram's worth of extra capacity, so we've got a fair amount of space on that one that we can use. But in general, people have asked us about having platforms that have like in-situ chemical sampling and things like that. For that sort of thing, what we do is we design a fuselage around us using the duct components that we already have and just change the exterior plastics. Thank you very much for listening.
Thank you.